Hello guys and welcome to Leetcode. Today we are solving the Leetcode problem number 162, find peak element. I first read the question and then discuss the approach with you. So the question says that a peak element is an element that is strictly greater than its number. Given a zero index in integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index of any of the peak. You may imagine that nums of -1 is equals to nums of n. In other words, an element is always considered to be strictly greater than the neighbor that is outside the array. You must write an algorithm that runs log of n times. Here, with log of n, you have to understand that we have to use binary search over here. So, first we will see the example that they are given to us. So in example number 1, input nums is equals to 1, 2, 3, 1. Here 3 is the peak element because 3 is greater than nums of I minus 1 and nums of I plus 1, and 3 is greater than both of its element. So we will return the index of 3. The index of 3 is 0, 1 and 2. So the index of 3 is 2. So we will return here 2. And here the peak element is 2 and 6 because they both are greater than its number element. Here you can see that 6 is greater than 5 and 6 is also greater than 4. And here 2 is greater than 1 and on other side also this is greater. So now see how we have to solve this question. What will be our approach? Let's go on to the. Okay, so for example, we have given the nums array. So here the output will be of this is 2 and 6. The output will be their indexes, means 2 have 1 index and 6 have 5 index. So we will return the indices. So the indices is our output. So what we have to do is we have to do a simple binary search. So first we will make a start pointer over here, which will be placed on the first element. Then we have to do an end pointer over here, and for that, from this we have to calculate mid start plus end divided by 2. Then we will calculate the mid. The index of start is 0 and the index of end is 1, 2, 3, 4, 5, 6 and 7. So mid is equals to 0 plus 7 divided by 2. Its value will be 6. Okay. 7 divided by 2 will be 3. So we'll go in third index 0, 1, 2, 3 means here. So our mid will be placed over here. So we'll check that if mid is smaller than its previous value. If mid is smaller, what we'll do, we'll check over here. And we'll put a else part that if mid is greater then it's another element. So we'll check in this part. Here the mid is greater. So we'll check in this part. So the mid will go in this. So the mid will become start is equals to mid plus 1. So our start pointer will go. Now this is our start. Now we will calculate mid again. So 4 plus 7 divided by 2. 4 plus 7 is equals to 11 and 4 plus 7 divided by 2 is 5. So now our mid element is placed over here. We will check that our mid element is greater than its previous element. So yes, this is greater. Then we will check that our mid element is greater than its another element or not. So no, it is not greater. So we will do nothing, and we will go on the condition that our start, if our start is greater than its another element or smaller than its previous element. So yeah, our start is greater than, then we will check our condition that if our start is smaller than its another element. So yes, this is smaller than our, so yes, 4 is smaller than 5. So what we will do is, we will just put our start pointer over here. Now the index of 5 is 0, 1, 2, 3, 4 and 5. The index of 5 is 5. Then we will calculate mid. So mid is equals to 5 plus 7 divided by 2. 5 plus 7 is equals to 12. 12 divided by 2. 12 divided by 2 is 6. Now we place our mid over here. Then we will check that if the mid is greater than its previous value. So yes, it is greater than its previous value. And then we will check that if the mid is also greater than its another value. So yes, this is greater. So we'll return its index. Here in this question, there is some trick. I will let you know that what is the trick. So what is we have to do that? We first have to check the base cases that if 6 is greater than its previous element, means the last element is our peak element. If the last element is our peak element, we have to return the index of this last element. And if our first element is our peak element, so we will return the index of this first element. And we will check another condition that if nums contains only one element, then we will return this one element. And if you see carefully, you will notice that there is some trick that you can see that all the numbers goes on ascending order. All the numbers goes on ascending order. 3 is smaller than its previous element. Four is smaller than 3. 5 is smaller than 4. 6 is smaller than 5. Here 2 is smaller than 1. 1 is not smaller than 2. So here we have to see that if 2 is smaller than 1 or not, means nums is smaller than nums plus 1. If it is not smaller, then we'll check over here in this side. So now let's see our code and what we have to do in code. If I code in front of you, you will understand it more clearly. So first we will make our base cases. If nums of 0 is greater than nums of 1, then we will return 0. Then we will check the condition for the last element, nums dot length -1 is greater than nums dot length -2. Then we will return the index of nums -1, nums dot length -1. Then we will check another base case, that if nums dot length is equals to 1, means the length of our array is 1, then we will return 0 only, because it is the biggest character presented in the array. Now we will do a simple binary search. So what we'll do is we will just make a integer start, which will place on the starting position of our array. Then we will make end is equals to nums dot length -1. Then what we will do is we'll make a base condition of our binary search, that if start is smaller equals to end, and what we will do is we will just make a int mid, then we will do start plus end divided by 2. So we'll calculate our mid. Then we'll check that if nums of mid is greater than its previous element or not. Then we'll check that if that nums of mid is also greater than its another element or not. If these both conditions go true, we'll return we have find our peak element, so we'll return mid. Else if nums of mid is smaller than nums of mid plus 1, then what we'll do is we will just put our search bar on the mid, and we will do start is equals to mid plus 1, else we will do end is equals to mid -1, and at last if no character is present, then we will return -1. Now let's see by running our code. So yeah, this is accepting all our test cases. Now let's submit our code. So yeah, it is submitting. So if you like the video, and if I add any challenge to your brain, any concept to your mind, and if you help with this video, please do like, share, subscribe, and if you have any query, please comment down below. I will be here for you.